আজকের আমাদের টপিক সুপারপজিশন অফ ওয়েভস। সুপারপজিশন অফ ওয়েভস এর আন্ডারে আমরা ফার্স্ট যে টপিকটাকে নিয়ে ডিসকাস করব সেটা হলো স্ট্যান্ডিং ওয়েভস or stationary wave. Stationary wave ব্যাপারটা এরকম, when two waves of same frequency and amplitude travel in opposite directions at the same speed, their superposition give rise to a new type of wave, and that is known as standing wave or stationary wave. এই হলো দুটো ওয়েভ। ফার্স্ট ওয়েভটার ইকুয়েশন y1 equals to a sin omega t minus kx. সেকেন্ড ওয়েভের ইকুয়েশন y2 equals to a sin omega t plus kx. Now, by the superposition of these two waves, the equation of resultant wave, that equals to y1 plus y2, and that equals to 2a sin kx into cos omega t. Here this 2a sin kx is denoted by a1, where a1 is amplitude of the resultant wave. Now, here in this resultant wave, amplitude কোথাও ম্যাক্সিমাম হবে, আবার কোথাও মিনিমাম হবে। যেখানে অ্যামপ্লিটিউডটা ম্যাক্সিমাম সেই পার্টটাকে আমরা বলবো অ্যান্টিনোডস, আর যেখানে অ্যামপ্লিটিউডটা মিনিমাম সেই পার্টটাকে আমরা বলবো নোডস। At antinodes, displacement and velocity is maximum, but pressure is zero. At nodes, displacement and velocity is zero, but pressure is maximum. Here, distance between two consecutive nodes, that equals to lambda by 2, but distance between nodes and antinodes, that equals to lambda by 4. Now, এই স্টেশনারি ওয়েভের কিছু এক্সাম্পল নিয়ে আমরা এখন ডিসকাস করব। ফার্স্ট যেটা নিয়ে ডিসকাস করব, দ্যাট ইজ ভাইব্রেশন in stretch string. Vibration in stretch string. Now, transverse stationary waves are formed on a stretch string fixed at both the ends, and here frequency of the stretch string, that equals to 1 by 2L into root over T by mu, where L is length of the string, T means tension force in the string, and mu is mass per unit length of the string. And here velocity of the wave in the stretch string, that equals to root over T by mu. Now, in the stretch string, this is the fundamental mode or first mode of frequency. Here lambda 1 equals to 2L, where L is length of the string, and frequency F equals to F1 equals to V by 2L. This is fundamental frequency of the stretch string. Now, in next case, This is second mode. Here lambda 2 equals to L and frequency equals to V by L, that equals to 2F1. This is second harmonic or first overtone. And in the next case, this is third mode of frequency. Here lambda 3 equals to 2L by 3. That means F3 equals to 3V by 2L, that is 3F1. This is third harmonics or second overtone. That means here the frequency ratio are 1:2, 2:3, and in general, here the frequency Fp equals to P by 2L into root over T by mu, or P into F1, where F1 is the fundamental frequency and P means number of loops. So in case of this vibrating stretched string, frequency is inversely proportional to length of the string. Frequency is directly proportional to root over of T, where T is tension force, and F is inversely proportional to root over mu, where mu is mass per unit length. So F equals to also 1 by L into D into root over T by pi into rho, where D means diameter of the string and rho means density of material of the string. Now next move to vibration of air column in a closed pipe. Vibration of air column in a closed pipe. A long pipe or a tube closed at one end is called closed pipe. So consider here is the closed pipe having length L. Here is first mode of frequency at the open end. Antinodes are close end থাকবে হচ্ছে গিয়ে nodes. Here the first mode, that is lambda 1, that equals to 4L, because this length is lambda by 4. So F1, that equals to V by 4L. This is fundamental frequency or first harmonic, where V is velocity of sound in air. In the second mode, here this is 3 lambda 2 by 4. This is antinodes, this is nodes, this is also nodes. Here in the second mode, lambda 2 equals to 4L by 3. That means F2 equals to 3V by 4L, that equals to 3F1. Here thrice of the fundamental frequency. This is known as third harmonic or first overtone. That means in case of closed pipe, fundamental frequency is V by 4L and the first overtone is 3F1, thrice of F1. Second overtone is 5 times of the fundamental frequency. For nth mode, lambda n equals to 4L by 2n minus 1 and frequency Fn equals to 2n minus 1 into F1, where F1 is the fundamental frequency of the closed organ pipe, and here n equals to 1, 2, 3, etc. Now, next move to open organ pipe. A pipe open at both the ends is called open organ pipe. Here is the open organ pipe. At the open ends, open এন্ডে কিন্তু অলওয়েজ থাকবে, ওপেন এন্ডে always থাকবে অ্যান্টিনোডস. Here this is lambda by 2 or lambda 1 by 2. That means lambda 1 equals to 2L. So frequency F1 equals to V by 2L. This is fundamental frequency in case of open organ pipe. Now in the second mode, this is lambda 2. Here lambda 2 equals to L. That means F2 equals to V by L. That equals to 2F1, twice of the fundamental frequency, that is second harmonic or first overtone. That means for the nth mode, lambda n equals to 2L by n and frequency Fn equals to n into F1, where n equals to 1, 2, 3, etc. Now, here is the end correction. The antinode at the open end of a pipe is not formed exactly at the open end, but a little outside. This is called the end correction. This is denoted by, this end correction is denoted by small e, and its value is equal to 0.6 r, where r is the radius of the pipe. If L is the length of the pipe, then for the closed pipe, L is replaced by L plus E, while for the open pipe, L is replaced by L plus 2E. This is known as end correction. This is all about stationary wave or standing wave.